shall we? In order for any programmer to learn a language, there are 4 key things that you need to really master for any sort of language, including Python. First are the terms of that language. Sometimes a programming language has different words and different definitions for these words that you're going to have to memorize. Things like statements, variables, instantiation. Really complicated sounding words, but you need to understand what they mean so that you can talk to other programmers. You also need to learn about a language's data type. That is, what sort of data can a program hold? You can think of it as values. Just like in real life, we have different ways to represent values, like numbers, letters, and symbols. In programming, we have these data types to store information. And each programming language has different sort of data types. Next, we need to learn about actions. At the end of the day, all programming is a way for us to tell our machines, hey, store this data and then retrieve this data and perform some action on it. That's all it is, just using memory and performing some actions. So we're going to learn how to perform those actions. And then finally, we have to learn the best practices of each language. There's good ways of writing Python code, and then there's bad ways. So that when we build our applications, our programs, well, we don't have a leaning tower like this, but we have a solid structure and a solid program. So throughout the course, we're going to learn about these things. But keep this in mind. These 4 things are what you need to become a good programmer. And I want to start the basic Python section with the data types. So let's get started. Let's learn about the Python data types, all the options we have in Python. Now we're back to our REPL.it, so we can write some Python code. We see over here that we're using Python version 3.6. That's great. Let's minimize this and start writing our first Python code. Now, we're going to talk about data types. And Python has several available to us. Now, I'm going to list them out for you, and then we're going to talk about each one individually. First, we have something called int. And you see right away when I type, I have the REPL already give me hint, and it's highlighting it. If I hover over it, it shows me that int stands for integer. We also have something called float. We have bool, which stands for boolean. We have str, which stands for string. List, tuple, set, and dict. Now, what are these? These are data types, right? A data type is a value in Python. So you can think of it as exactly that, values. So int would represent all numbers, for example. String will represent all letters, for example. And a program is simply instructions that tell a computer what to do. And what does that mean? It's all about storing information, or a data type, and modifying that information. We're taking actions on these data types. So the 2 crucial steps when learning a programming language is that, well, we have these data types that we need to understand that exist in a language, and then we need to learn how we can manipulate the data, create, store, read, change, remove this data from the machine. Now, these data types are called the fundamental data types in Python. They are the core to the language. Now, after the fundamental data types, we also have something called classes. So beyond these data types, we can actually create our own using something called classes. So these will be custom types. Again, something that we'll learn about. So I can create a class that I can name whatever I want. For example, supercar. Now that doesn't exist, but I can create it. And we'll explore how to do that in the course. Now, besides the fundamental data types, the classes, which will be our own custom types, we also have something called specialized data types. And these specialized data types, they're not built into Python, but they're special packages and modules that we can use from libraries. Now, again, this is a topic that we'll cover later, but these are, you can think of it as extra boosts. Whenever we don't have a data type that we want in the standard Python package, and maybe we don't want to create our own custom types, there are specialized data types that we can use from what we call modules. So you can think of it as extensions that we can add to the language. Again, something that we'll talk about later on in the course. And then finally, there's another type that is a little special called none. And none, as you can see, it's being highlighted, which means it means something in the language. None, as the name suggests, means nothing. It's kind of like the idea of zero in math. It's the absence of value. It's simply nothing. And you'll see why this is important in programming later on. So these are our data types that we're going to talk and we're going to use in our language. Now we're going to start with the fundamental data types, which are nice and simple for us to get through. So let's start one by one. And you know what? Let's start with these two for now. I'll see you in the next one. Finally. So if you're watching the videos, don't worry. This is good. You want to use the latest version of Python. All the code is still going to work. But keep in mind what I said before, which is that these versions are constantly going to be upgraded. This time around, we're using the latest, which is great because when we go to python.org and we go to downloads, we see that 3.7.4 is the latest. Awesome. All right, let's get back to learning. Let's talk about our first data type. And you know what? Let's do two at the same time. We have int and floats. Int stands for integer, as you can see here, and float stands for a floating point number. Let's explore that. First, let's start off with integer. An integer is, well, a number. 3 or 4 or 5, these are all integers. In a programming language, you can use integers to do mathematical operations. For example, 2 plus 4. If I run this, well, nothing gets printed because, again, we have to perform some action on these data types. And one action that we've learned so far is this idea of printing. And we print something by calling the print keyword with the brackets. So the brackets is almost like saying, hey, perform this action on these data types. And if we run this, we get 6 right here. Awesome. So not only are we using print, but we're also using the plus sign to perform an action to add the two data types together. And as you can imagine, we can do most mathematical operations, the basic ones. We can do negative. We can do, let's say, 2 times 4. And then we can also do 2 divided by 4. And if I click run here, all right, it looks like everything is working. We've added, we've subtracted, we've multiplied, and then we've also divided. Now here's the interesting part. Up until now, we've used what we call integers. That is, these are whole numbers. There's no decimal places. They're just, well, integers. And a neat trick that I can do here is I can actually say, hey, what's the type of 2 plus 4? If I click run here, all right, let's decipher what just happened. I've taught you another action that we can perform, which is something called type, which tells us, hey, what data type is this? And just like in math, we go bracket by bracket. So the first part, Python says, hey, what's 2 plus 4? Well, that's going to be 6. And it's going to say, hey, what's the type of 6? Well, the type of 6, that's an integer. So it's going to say class int. We don't have to worry about the class keyword for now. That's something that we'll talk about later. But we see here that we're using int for integer. And then finally, after this gets evaluated by Python, we print out whatever this does, which is class int. Now, check this out. Let's do the same for all these ones as well. So we're going to say type here, and then type here. And if this syntax is intimidating, don't worry. This is something that you get used to. If this is your first programming language, it is not going to be easy because, well, if it was easy, then everybody would be doing it. So hang in there. Trust me, as you practice more, this is going to start making more and more sense. Now, before I click run, what do you think the output of each one of these lines are? Ready? Give it a guess and let's click run. All right, we got int for 6. We have -2 here, which is also an integer. We have 8 here, which again is also an integer. But then we have float, because 2 divided by 4 is 0.5. What is that? Well, remember, we are talking about 2 data types here. We're talking about int and float. And float is what we call a floating point number. A floating point number is simply a number with a decimal point. In our case, this is 0.5. So it's a floating point number. So if we write a number, let's say we'll do print type, and then I'll say 0.00001. What do you think we'll get? Well, we would get a float. If I do 5.0001, again, we'll get a float. What about the number 0? If I click run, I get an int because, well, there's no decimal points. Why do we need to make this distinction in programming, and specifically in Python? Well, it's because a float takes up actually a lot more space in memory than an integer, right? Because remember, this number, the number 6, this needs to get stored in memory on our machine. And remember that machines don't really understand this. They understand zeros and 1. And they store this number in something called a binary, or binary numbers, which is zeros and 1s. Now, the problem is when you have decimal places like 0. Or let's do 10.56, it's hard to represent that in a binary number, zeros and 1s, because of this point. So a floating point number essentially stores these numbers in 2 different locations, one for the 10 and one for 56. Now, we don't need to get technical here, but that's the idea. The idea is that we need more memory to store a number like this than a number like this. Now, the topic of floating point numbers is really, really interesting, and I'll link to a resource. But the best way to learn more about floating points, again, it's not super important that you know the technical details. But if you go to floating point number Python, again, you want to make sure that you go to the documentation for version 3. And you can actually learn about floating point arithmetic. And these official documentation by Python are always a good tool for you to use whenever you get confused about something or you want to get a little bit more extra detail. But let's get back to the topic at hand. both int and float are used for, well, numbers, right? And Python is going to automatically format the type to whatever, well, makes sense. For example, if in here I do 20 plus 1.1, one is a integer, the other one is a floating point number. But when I click run here, automatically Python is going to convert it to float. Let's remove these here so that we don't get confused by them. So if I run this, we see that this whole expression is converted into, well, a float. Now, if I do, let's say, 9.9 here, which will equal to 11, and I click run, these two floats add up to, well, still a floating point number. Because if I remove the type from here, and I click run, it gives me the result 11.0. It keeps the floating point numbers. All right, but at the end of the day, what we care about is that Python works the way we expect it to. That is, we can do mathematical operations. As a matter of fact, we can do a few other things as well. There's also this idea of the double multiply. So this means to the power of. So 2 to the power of 2, well, that's going to equal 4. 2 to the power of 3 is going to equal 8. We also have the double divide. That is, we can do 2 divided by 4. But then we use 2 slashes here. If I click run here, I get 0. This actually returns an integer, rounded down. If I do 3 divided by 4, I get 0. But if I do 5 divided by 4, I get 1. This gets rounded down to an integer. Finally, the last operator that we're going to learn about is called modulo. And it looks something like this. If I do 5 modulo, which is the percent sign, divided by 4, or modulo 4, if I run this, I get 1. Modulo is used to represent what's the remainder of this division. So if I divide 5 by 4, the remainder of this division will be 1. If I do 6 divided by 4 with modulo, and I run, I get 2. 2 is the remainder of 4. All right, let's take a break and learn a little bit more about these numbers in the next video. Let's continue our understanding of int and float. We talked about the idea of these two data types and how we can use operations on them that we're familiar with from math class, plus a few ones that maybe we haven't seen before, such as modulo or the double slash, or the double multiply for the power of. Now, this is really cool because we can get our computers to do, well, math for us, like a calculator, right? But a programming language also provides for us different actions that we can perform. Now, besides these ones, we also learned that there's a type action that we can take, there's a print action that we can take, but there's also specific math type functions that int and float are able to use that are built into Python. Now, these are called, well, math functions. And functions, something we'll talk about later on, are these actions that we've been talking about. Remember our diagram here? We're starting to learn about the data types and the actions that we can perform on them. Now, in most programming languages, these actions are called functions. And we have a whole section on them. But for now, there's some functions that we can use. So this is a print function, this is a type function. But there's specific math functions. such as round. And you see right away when I type, REPL is a tool like an IDE that hints and tells us what we can add. So it says round and give me a number and maybe an nth digit. But let's just worry about the first one for now. So round, if I do 3.1 and I round here, I get 2. Well, that's not right? That's actually the result from up here, because we need to also tell it to perform with a function of print. Hey, print to the screen whatever the result of this is. And just to make things easier to see, I'm going to comment this out. So I'm just selecting everything and then pressing Command/, or if you're on Windows, Control/. If I click Run, I get 3 because I'm rounding down the number. So let's say if it was 3.9, I click and I get 4. Again, I'm rounding the number. Another math function that's built into Python is something called ABS. And you see right away that I get ABS here. And ABS returns the absolute value of the argument. And again, for those that aren't too familiar with math, an absolute value simply means, well, no negative numbers. So an absolute value of negative 20 is 20. And now, because we know about math functions, I can start Googling, right? I can say, hey, I'm a Python programmer and I want to learn about math functions. Well, I can go Python 3 math functions. And look at that. Right away, Google tells me that there's a ton that we can use. You don't have to memorize all of these. As a matter of fact, some of these I've never ever used in my programming career. But it's good to know that they have these tools available to you. And as a programmer, this is something that you'll have to get used to. The idea that you won't actually memorize every single action that we can take for each data type. Because some of these are very rarely used. Some of them you'll never use in your career. The key is to understand how to Google them and how to find them. And throughout this course, I will show you the important ones that you're going to see over and over and over. But as a way for you to develop as a programmer, at least you know that this is how you look for answers and find out that, hey, there's different math functions that we can use with numbers. All right, let's take a break and continue in the next video. Bye-bye. These are the topics that are going to be super, super short, but important because as a beginner, it's hard to learn these things because you don't know what you don't know. So what I'm going to try and do in these developer fundamentals is tell you, well, how to avoid the mistakes that I made when I got started and what a lot of people do when they get started. That is, they don't have a clear path and don't understand what the most efficient way to do things is. So with developer fundamentals, we're going to talk about key things to make you, first of all, efficient in learning Python, but also make you a programmer that is really, really good and that companies want. So what is this first developer fundamental? It's don't read the dictionary. What does that mean? Well, when you're learning a language, such as Python, you're going to have a tendency, especially when you're starting out, to try and learn every single thing, every single function, every single syntax, every single trick. It's almost like you're trying to learn a language by reading a dictionary from page 1 all the way to page, 1,200. But that's not how things work. As a matter of fact, when I work with different programming languages, I don't know all the syntaxes. I don't know all the methods and functions. And what a lot of developers do is not necessarily memorize everything, just like you would every single word in a dictionary. Instead, you understand what exists and what you can use, but you can always Google things. And most of the time, developers are Googling things, no matter how experienced they are. For example, if we go to the Python documentation here, we can go through everything, right? I can go through the language reference and read through everything. And this is really, really useful information. But you're not going to memorize every single thing about the language because there's a lot. This is the Python language, and then there's also the libraries, the standard libraries that we can use. And if you sit through here and just read everything in here, well, you're not going to memorize anything. In order for you to actually learn Python, you have to use the language. And you'll notice that some things are used a lot more than others. Just like in human languages, like when you learn English, there's really difficult words that don't get used that often. And there's words like and, the, or apple that get used very often. So we're going to learn the language in a way that makes sense, in a way that's efficient, where we focus on the 20% that gets used 80% of the time. And all these smaller, more complicated things we're going to cover, but we're not going to cover one by one from start to finish. We're going to jump around. The idea being that when you learn a programming language, you're just using these concepts and slowly you're learning what's out there so that when you have a problem, you can identify it and remember, oh, I think Python has a pathlib library that I can use. Or perhaps remember that, oh, I can use tuples in Python. So your first developer fundamental is this. Don't learn a language as if you're trying to get 100% on a test. We're going to learn a language by actually using it, focusing on the things that actually matter. All right, that's enough talking for me. I'll see you in the next video. Bye-bye. Let's talk about an important term when it comes to programming, and that is operator precedence. Now, what does that mean? Again, we're using our knowledge from math class. It's the idea that if I do 20 plus 3 times 4, it means that different operators have precedence over different ones. That is, we multiply this first, equals to 12, and then 20 gets added to 12. Because the Python interpreter is going to follow a basic set of rules. For example, if I do 20 minus 3 here, and let's print this out, click run, I get 8. Because 3 times 4 gets evaluated first, which equals to 12, and then subtracted from 20. It's not that this goes first and then we multiply 17 by 4. And this operator precedence shouldn't be new, right? If you've taken any sort of math class, you understand that this is how, well, math works. And this works the same in all programming languages. So the order is this. First, we follow the brackets. So whatever is wrapped in a bracket, we do first. The second is we do the power of. So whatever is done in the power of will be after parentheses. For example, if I do parentheses here, and then to the power of, let's say, 2, or let's do plus 2 to the power of 2, well, the first operation that will happen is 20 minus 3, because that's the first precedence. And then we do 2 to the power of 2, because that's the next precedence. And then only after we do that, we add these two together. If I click run, I get 21, which again makes sense. 17 plus 4. After the power of, we have the multiplication and division. And then finally, the last precedence is addition and subtraction. Now, this isn't going to be a math class. Some people really love math. Some people really don't. But I want to just give you this basic understanding of operator precedence when you see it. We'll do some exercises here to get accustomed to it, but trust me, this is as mathy as we're going to get in this course. The math part of the course is, well, just here. It's going to get a lot more interesting as we learn about different data types. I'll see you in the next one. Bye-bye.
This is a quick optional video that, well, with something that you probably won't use, but I want you to just know that it's out there. And that is, there's actually an extra data type that I didn't talk about, and it's called complex. And as the name suggests, it's pretty complex. However, a complex number, again, is a number that is a third type. Instead of int and float, we also have this type for numbers. Now, the reason I'm not really teaching complex is that you only use this if you're doing something really, really complex math. Most of the time, you'll never use it. I personally have never used it, but it is good to know that it exists. It's the equivalent to a real number, and you can read about complex numbers if you want. But again, that's something that you don't need to worry 99.9% of the time. Another thing I want to talk to you about is this idea that these integers and floats get stored, such as 5, in memory as binary. That is, as binary numbers, ones and zeros. And there's actually an action or function that we can use in Python called bin for binary. And you can see that a bin returns the binary representation of an integer. So it's going to return whatever the binary version of 5 is. If I click run here, well, I have to print, remember. So let's print and click run, and I get the binary representation. Now, instead of all zeros and ones, there's also this idea of b. And that is what Python uses underneath the hood to say, hey, when I see this number with 0b, that's a binary number. But if I Google binary number 5, I see that the binary number for 5 is 101, which, again, that's what we see here. So that's really cool, really interesting just to know that it exists. By the way, just for fun, let's say that we want to return this into a decimal. Let's say we're the computer and we just retrieve this binary number. I can do int and then wrap this like this in single or double quotes. And then with the int, I can also say, hey, I want this return to a number that is base 10, which is what us humans use. So if I actually do print here and click run, well, actually we have to do base 2 here, right? Because what we're saying is, hey, this number is base 2 and convert it to integer. And base 2 number is, well, zeros and 1. It's a binary number. So if I click run here, look at that. I get 5. So in your head, you can think of it this way. When we store a number like 5, an integer like 5, when a computer retrieves that number, let's say we're doing some addition, well, it's going to grab this from memory. It's going to say, well, this is a binary number, and I'm going to convert it into integer. Very, very cool. Now, the reason I taught this here, you won't see this a lot in beginner courses, and especially so early in the course, but I think it's an important principle. Although you might not get tested on this ever, for you to just understand how things are working underneath the hood, I believe is an important thing for you to do in order to become a great developer. So hopefully this doesn't confuse you too much. I'll see you in the next video. Bye-bye.